For section 1.9, dealing with distance and midpoint formulas, including circles, you have these formulas here that we'll break down in just a moment, but first with our learning objectives, which are also featured on your outline that you should have received for this section. Find the distance between 2 points, so graphed out on an xy plane, how far are the 2 points? Find the midpoint of a line segment, so what's the halfway point, halfway between the 2 points? Bon Jovi once said we're halfway there, so the midpoint formula gives us a little bit of intel as to how that's all done. Write the standard form of the circle's equation given here. In addition, giving the center and the radius of a circle, write the equation in standard form. This fifth one's more of a bonus, so if you're interested, let me know, but we'll mostly be dealing with the first 3. So we have these formulas here, which should look familiar if you've taken geometry or if you were lucky enough to get here in your Algebra 2 course, where midpoint formula allows us to decide on pretty much where the middle point between 2 points is when graphed out. The distance formula tells us how far the distance is, and you'll see that this kind of looks like Pythagorean theorem. So if you can recall what that is, that a squared plus b squared equals c squared, this is kind of a mock version of it because you have some term being squared and you're adding on another term being squared, and then it's as if you're just taking square roots on both sides to get some distance. We also see the equation of a circle where for h and k, this is considered the center of the circle. So the center would be some point like hk, and then this r is the radius of the circle, but the radius is being squared. That's a really important thing. So you might see general equations of a circle that look like this, x squared plus y squared equals 4. Which can totally come up. This is pretty much saying that it's a general circle where the center is 0, 0, and the radius is going to have to be 2. So notice that. For the first example, we're finding the distance between 2 points. I'll show the visual on this, and then I'll give you a little bit of detail with what formula we would need. So it's as if we have these 2 points seen here. We have point A, and we have point B, and the question is asking us to find the distance. So pretty much saying how long is this line from point A to point B? Is it a certain number of units? Can we find this? So this is different because this is not on the same line. We need to be a little strategic with this. And if you started to notice that the equation looks like Pythagorean theorem that we saw on the outline, you'll start to notice that this can definitely make a right triangle if you just add a leg here to here. So we'll see what's up with this. If we're finding the distance using the distance formula, we're taking the square root with our x terms. So I'm going to denote this as x1, y1, x2, y2. So if we have x1 subtracting x2, this is going to be -1 subtracting 3. Where this is being squared, we're adding on 4, then subtracting a -2, where this is all being squared. -1 minus 3 is going to give us -4. We're adding on 4, subtracting -2, so 6 being squared. Keeping in mind we're taking square roots for everything here, so this is going to be 16 plus 36, taking this square root. This is going to be approximately the square root of 52, which you could say is a little bit more than 7, closer to 7 than it is to 8. So we can definitely say that. We can kind of see that based off of the graph where this is traveling a little bit of a distance. So you could say that your change in x really was 3 or 4 units, and then your change in y was 6 units. So you can kind of use slope here in a way, but square root of 52 is going to work the best. So as an approximation, 7 units. I know there's a decimal there, but that's how we would do that one. And ideally it makes sense because using the distance, we use the distance formula. So this will look like slope formula also, so you can use that intel from previous sections. Now going with the midpoint of the line segment with negative 3, 5 is 1 point, which I'm going to call point A, and point B as negative 1, negative 3, where those are the endpoints. So we are trying to find the midpoint. So I think sketching these out is an extra step, but it's definitely helpful. So let's say that we get rid of this, and we were going to graph out these 2 points, negative 3, 5, negative 1, negative 3. So what this is saying is that there's some midpoint that's on this line. There's some point like between the blue line, or sorry, the blue dot and this blue dot. There's some point that's dead set in the middle. So think Bon Jovi, we're halfway there. We're trying to find that halfway point. So midpoint formula, you see this up at the top. This is what we're going to need. This is adding up our 2x values and taking half of it. So our 2x values here are negative 3, and we're adding on negative 1. We're taking that for the x coordinate. So this is the x coordinate in disguise. We'll simplify this in a second. The y coordinate is going to be the sum of the y coordinates. So we have the 5. So the 5, that was from here, and we're adding on the negative 3, that was from this point here. Try not to draw too many arrows in these videos because it can get a little confusing. But negative 3 adding on negative 1 would get us negative 4. 2 is still in our denominator. 5 adding on negative 3 would get us positive 2. This is all over 2. We can touch this up a little bit because we know fractions. Negative 4 over 2 can be simplified to negative 2. 2 over 2 we can simplify to 1. So this is saying that the midpoint between point A, negative 3, 5, and point B, negative 1, negative 3 is negative 2, 1. And we'll double check this since we're smart and we use additional tools. So let's think this out. This is saying that negative 2, 1 is going to be halfway. That looks about right. So look at this very closely. We have these 3 points. This looks as if it's about halfway in between. There's a change in x of 2 units. So this is 1 in between. Change in y is 8 units. So the halfway point would be 4. So it's 4 up, 1 left, 4 up, 1 left. So you can kind of think of this like SOAP formula if you want. So we got those. Dealing finally with the circle formula, which I think is the most tedious, so we'll take our time on this. So we know that the equation of the circle should look like x, where x is your variable. You're then deducting h, which is the x coordinate of the circle. And this is all being squared. You're then adding on y minus k, where k is the y coordinate of the circle. And this is all equal to the radius, which they denote as r, but the radius being squared. So this is kind of another subtle form of the Pythagorean theorem. And so when they say write the standard form of the equation for a circle with this information, they're saying pretty much take this information and put it in there. So we can still write down parentheses x. We can still deduct now with our x coordinate of the circle, or the circle center rather. Let's make it plural, or sorry, possessive, circle's center. So x minus negative 8, where this is being squared. We're then adding on y minus now 5, where this is all being squared. This is equal to the square root of 11 being squared. So what exactly could we touch up here to make this easier or make this better to work with? What can be rewritten to make it a little bit cleaner? Hopefully you're saying the x coordinate, since you're subtracting negative 8, you could say this is x plus 8 being squared. You're then adding on, still y minus 5 being squared. But now this is equal to 11. And why is this 11? What changed? Well, you have the radius, which was root 11, and that has to be squared if you're using the standard form equation of a circle. So this is considered the standard form. There is nothing we can really simplify. We see that the binomials are being squared. We see that our radius is there being squared. So let's plot this out just so that we have closure. And because we like the visual interpretation. So we have x plus 8 being squared. X plus 8 being squared. And then adding on y minus 5 being squared, where this is all equal to 11. So if we look closely at this, and we'll even let's mark up our center of negative 8, 5, which we'll label as our center. If we look very closely, the center is definitely what we wanted, negative 8, 5. And if we also look at the radius, root 11 is approximately between 3 and 4. So it makes sense that from this center to this point here, to this point here, and to this point here, it looks as if it's a little under 4 units. So I'm pretty content with our answer here for this. For the last problem, if you want to try it, go for it. If you're curious about it, let me know. But eventually, you end up trying to complete the square. I'll give you a hint on this. If you want to try this, go for it, but it is extra. So try to complete the square for x and y. If you're not too sure about this, you can ask me about it, but I don't plan on assessing you for this. If you have any questions, please reach out through email or ask a question in class. Thank you.